All right, let's dive in. Every country has a constitution, right? A set of fundamental rules that everything else is built on. But what if? What if the universe has one too? That's what we're digging into today. A pretty wild new theory that proposes exactly that, a constitution of the universe. So, let's just start with this quote. It's straight from the paper. It says, "Physical law is not postulated. It is the inevitable envelope of admissible phase closure." Yeah, I know, right? If that sounds like total nonsense, hang in there. I promise, by the time we're done here, that sentence is actually going to make a whole lot of sense.
The paper we're looking at today kicks off with a massive question, one that kind of shakes the foundations of everything we think we know. What if the laws of physics are just an illusion? So, if our laws of physics are an illusion, what are they an illusion of? Well, that brings us to our first big idea. They're basically shadows of reality. The theory's most powerful claim isn't that Einstein and Schrödinger were wrong. Not at all. It's just that they were seeing an incomplete picture. The paper calls our familiar laws structure-hiding representations. Think about it like this. Imagine you've only ever seen the shadow of an object on a wall. You could study that shadow, right? You could measure it, you could even predict its movements, but you'd be missing the real three-dimensional object that's casting it. The argument here is that our laws of physics are just like that shadow. So what exactly is a structure-hiding law? Well, it's any law that looks smooth and fundamental on the surface, but is really just a simplified snapshot of something way more complex and discrete underneath. You want a perfect analogy? Think of a fan. When the blades are spinning really fast, you don't see individual blades, do you? You just see a blurry continuous disk. Our laws of physics might just be that blurry disk, hiding the true blades of reality. Okay, so if our laws are just shadows, what's the real object casting them? The paper proposes a whole new cosmic rulebook. It's this fundamental architecture for reality, and it's built on a pretty simple three-layer hierarchy. The theory basically says reality is built like a computer. Way down at the bottom, in layer I, you have the prime phase rules. This is like the computer's deepest firmware, the absolute most basic rules that decide what is even possible. Then, layer 2 builds on top of that to create spacetime. Think of this layer as the operating system, like Windows or iOS. It's the structure that allows things to actually happen. And finally, layer 3, well, that's what we see. That's our user interface. All the laws of physics we know and love live here, but they're just a surface-level story about what's really going on in those deeper layers. But here's where it gets really elegant. This entire ridiculously complex reality isn't run by a bunch of complicated rules. The paper argues that the whole thing, the whole shebang, is driven by just two fundamental master laws.
Just think of these two laws as this perfect tag team. The first one is a structural filter. Its only job is to ask, hey, is this shape or structure even allowed to exist? It's kind of like a bouncer at a club checking IDs. If a particle's structure isn't on the list, sorry, it can't exist. The second law is the update rule. So for all the particles that do get past the bouncer, this law tells them how to move and interact. It's the engine that drives all of reality's action. Now, this is the crucial point, so listen up. The framework doesn't just pile new ideas on top of old ones. No, it claims that all the familiar equations we use, everything from the Schrödinger equation to Einstein's field equations, they all just emerge naturally as simplified projections of these two master laws. So how in the world do two simple laws build everything from gravity to quantum mechanics? The theory says they do it in stages, creating these distinct layers of reality it calls structural shells. Now, these shells, they're not like the layers of an onion. A better way to think of them is like different zoom levels on a fractal. They represent how many connections, how many steps you are away from the absolute center of this network. And just like when you zoom in on a fractal and new patterns emerge, zooming into each of these shells reveals a completely different set of physical laws that are in charge. For instance, this theory suggests the universe doesn't kick off with a big bang. Instead, it begins at shell 2. This is the first level where the structure is loose enough for things to actually start moving around, for cause and effect to even begin. It's like the first spark of a dynamic reality. Okay, get ready because this is where it gets absolutely mind-blowing. One level up at shell 3, gravity just appears. It emerges. In this model, gravity isn't some fundamental force pulling things together. Nope, it's just a side effect. It's the fabric of space-time snapping back into shape. The paper calls it curvature elasticity. And the amazing part? From where we stand, This looks exactly like Einstein's theory of gravity.
Then let's jump to shell 5. This is where the quantum realm appears. So in this model, all the weirdness of quantum mechanics isn't some ultimate truth of reality either. It's just a feature that takes over at this specific zoom level, and it all emerges from a stable rotational pattern in the underlying network. Okay, so this is a fantastic story. It connects prime numbers, geometry, gravity, quantum mechanics. But is it just a story, or can it actually be tested like a real scientific theory?
The answer, according to the paper, is a big yes. It says this framework is way more than just speculation because it makes concrete, falsifiable predictions. And that, right there, is the key to good science. If you're wrong, an experiment has to be able to prove it. So what can we actually go out and test? The paper gives us two big ones. First, it predicts that our current quantum equations, they're not quite perfect. It says if we crank up the energy in a particle accelerator high enough, we should see a tiny, specific error, a little wobble, where reality doesn't behave quite like we expect. If we find that wobble, this theory gets a huge boost. Second, it predicts a kind of universal breaking point. The idea is that if you push on any system hard enough, you could hit a threshold where the basic rules of its behavior just suddenly change. These aren't just ideas. They're actual, concrete questions we can ask the universe.
And that leaves us with a final, pretty profound question to think about. This framework suggests that underneath all the incredible complexity of our universe, from galaxies all the way down to quarks, there might be this simple, elegant constitution based on just two master laws. So could our universe really truly be built on a simpler foundation than we ever imagined?